Hey guys, today we are looking at 3.3's notes, which is all about completing the square. Now, completing the square is a topic that I covered very briefly in Algebra 1, and at the time I said, hey, if you're too tripped up by this and you're really confused by it, don't really worry about it. We'll cover it again in Algebra 2. Yay, we're at that point in your lives now, and we're in Algebra 2, and it's time to really have a better understanding of completing the square. So before we get into that, I do want to take a little bit of time just to go back through a couple of factoring problems because it'll help us understand the process of completing the square. So for these first two problems here, if we're asked to solve each one of these by factoring, because of the way that our equations are set up where it's just x squared for my leading coefficient, it's just a 1, I can factor this using our regular old school two parenthesis factoring, where I'm looking for, okay, my first two terms we know are x and x because x times x is x squared. For the other two, I'm trying to figure out what two numbers multiply together to give me 16, but add up to a positive 8, which in this case would be positive 4 and positive 4. 4 times 4 is 16, but 4 plus 4 is 8. So if I was going to solve this, I get each of these parentheses set equal to 0, which I'm only going to really show you once because it's the exact same thing for both of them. So here, when I subtract 4 on both sides, I get x equals negative 4. Now, eventually, we'll say that this solution is repeated, slash it has multiplicity of 2, but that's for later on down the road section for chapter 3. For right now, as long as we understand how to get x equals negative 4 for a solution, which we should be able to because that's what we did in 3.1. That's all we're doing for these problems. For part B, this one we've got x equals x minus 6, x squared minus 6x plus 9 equals 0. Once again, it's just an old school two parenthesis factoring process because it's again x squared for the leading coefficient, the leading term. So now we're trying to figure out what two numbers multiplied together to give me a positive 9, but add up to a negative 6. Which the only way to do that is to have two negatives, right? Because a negative times a negative would make it positive for the multiplication, but a negative plus a negative is a bigger negative number. So in this case, x minus 3 times x minus 3 would give me x squared minus 6x plus 9. So again, I set my parentheses equal to 0. I add 3 on both sides in this case, and I get x equals positive 3. Now with both of these, because I was multiplying the same parenthesis times itself, we do have a special name for this, and it's something we talked about, one of our two special multiplication or factoring methods back in Algebra 1. This is what we called a perfect, if I can spell, square trinomial. Because trinomial, again, there's 3 terms in my simplification, and it's a perfect square trinomial because another way that we could write this would be x minus 3 parentheses squared equals 0, instead of saying x minus 3 times x minus 3, which, again, now we had problems like this on the 3.1 homework, where here I could just take the square to both sides instead of going through and doing the factoring process. X minus 3 equals plus or minus 0, which is just really 0. So when I add 3, I once again get positive 3 for my solution. Now, what we're going to be doing today is kind of hacking this problem a little bit, because if you look at the equations that we started with, 8 and 16 are both multiples of 4. Negative 6 and 9 are both multiples of negative 3. But it happens in a very specific way, where hopefully we notice, again, we see the word perfect square in our name of this special kind of factoring process. Because if you look at this 9 could be written as negative 3 squared. And this negative 6 here, well, that's just 2 times negative 3. If that pattern holds for my other one, that would mean this has to be 4 squared. And this is 2 times 4, which is true. So in general, this process, whatever my equation factors out into, that binomial, x minus 3, x plus 4, that number there is going to be the square root of whatever this third term is, because it's perfect square, and this middle term is just that number times 2. So What we're doing for this process that we call completing the square is utilizing this pattern to my advantage. So I'm going to be taking things that are not perfect square trinomials and kind of forcing them into that pattern, where my b value is 2 times whatever it factors out into, and then that third term, my c value, my constant, is going to be whatever that number is squared. So the way that we'll do this, and I'll walk you through the steps kind of simultaneously while doing number 1 here. I'm going to try and make sure I leave both of these up here so you can see them simultaneously. So with these are my 5 steps that are needed or necessary for completing the square. So first things first, just like we had up above, we need to make sure that our leading coefficient is just 1. So if there's anything attached to your x squared, you're going to divide through the entire problem by x squared. So here for number 1, that's already done. We don't have to worry about that. It's already x squared. So step 1 complete. For step 2, we're going to isolate all the variable terms on one side of the equation. So in this case, our x's, both x squared and x to the first power, need to be on the same side. It doesn't matter which side, but it needs to be on the same side, which again, step 2 for this particular problem is already done. Step 3 is where we actually do the completing of the square. So remember, if this was a perfect square trinomial, this middle term here, which is 6, would have to be 2 times something if it was a perfect square trinomial, which in this case, that something would have to be 3. So 3 is my number it's going to factor out into, which means right here in this empty space, the way I usually do it, because there's usually some steps here, I'll say, all right, this is x squared plus 6x, I leave a space, equals -8. Because then what we're going to be doing here, just like step 3 says, you're going to complete the square for the resulting binomial by adding the square of half of the coefficient of x to both sides of the equation. Now, I want to simplify that down for you because this is the process that I usually use. I just say that we're adding half of b squared on both sides. That is the simpler way of what that statement is for number 3, for step 3. So whatever my b value is, that thing that's attached to my x value, half of that squared is what I'm adding on both sides. So you can leave it as saying half of b. So in this case, if I add 6 over 2 squared on both sides, I can leave it that way. If your brain just goes ahead and says, all right, well, that has to be 3 squared, then you can do it that way as well. Either way, once you do this, so again, if I wanted to rewrite it and say, all right, alternatively, I could have said x squared plus 6x equals -8, and my brain does 3 squared on both sides. Now, I actually don't even do the step, like, I don't actually evaluate the squared on the left side because we know from up above this number that was squared, so the thing I'm highlighting right here, this number that is squared, is just what my parenthesis ended up having inside it. So instead of squaring it, seeing it as 16, and then factoring it after that, I just go ahead and skip that process because it's always going to factor out into x and then whatever half of b was. So in this case, it was +3, so x plus 3 squared. That will always be the process. If half of b was -16, it would be x minus 16 parentheses squared. It really is just very straightforward. You're just using that half of b value squared on both sides. On the right side, we do have to evaluate this because we have to combine them together into a single number. So now, which is what this last step, so step 4 is what I just did. Factor the resulting perfect square trinomial and write it as the square of a binomial. So that again is taking that 3-term thing and factoring it down into just x plus 3 parentheses squared. So that's that process. On the right side, 3 squared is 9, so -8 plus 9 gives me a +1. So now we've got it into a process here where we could solve using square roots, just like I did up above over here for x minus 3 parentheses squared equals 0. I'm going to do the same process. I'm going to go ahead and we'll use this yellow. I've got my squared term by itself already, so I can take the square to both sides. That gives me x plus 3 equals plus or minus 1, because the square root of 1 would be 1. But again, since we're solving with a square root in an equation, it brings up the possibility of plus or minus. So then from here, I subtract 3. That gives me the two possibilities of x equals positive 1 minus 3 or x equals negative 1 minus 3. So we have our two solutions of negative 2 and negative 4. Those are our two solutions for this problem. Okay, trying another one, number 2 here. We've got x squared minus 10x plus 29 equals 10. So now step 1, make sure it's just x squared by itself, which we're good. Step 2, make sure it's just the variable terms on one side. So here I'm going to have to subtract 29 on both sides. That gives me x squared minus 10x. I'm going to leave that space equals negative 19. From here, I'm going to add half of b, which in this case, half of negative 10 would be a negative 5. So half of negative 5 on both sides, or sorry, half of b, so negative 5 squared on both sides. Now, I write it as negative 5. We know negative 5 times negative 5 is going to be a positive 25, but I always leave it as half of b because this next step here, where it factors out, it's always x and then whatever half of b was. So in this case, because half of b is negative 5, my answer ends up being an x minus 5, parentheses squared. Over here on the right side, it doesn't make a difference. Negative 19 plus 25, because negative 5 squared is still 25. I still end up with a positive 6 over here. So that's the big difference here. If it is a negative b value, your answer is going to factor out into a negative, so x minus 5 in this case. Excuse me. From here, I'm still going to go ahead and start by taking the square root of both sides. I end up with x minus 5 equals plus or minus the square root of 6. Here, square root of 6 does not simplify, or not really just here, but negative square root of 6 does not simplify into a nice whole number. So you've got two different ways of handling this, and it really depends on what the application is that you're doing for the problem, or what the instructions tell you. If you have to approximate the answer to 2 decimal places, then you'd have to use a calculator for what square root of 6 is. If it doesn't specify, you have the choice. If you wanted to, we could go ahead and just add 5 on both sides. That looks like a 6. We're going to do that again. Add 5 on both sides to get that x equals 5 plus or minus the square root of 6. And that would be totally okay for you guys to leave your answer as. You can leave it in radical form. You don't have to put it as a decimal unless I tell you directly or put in the instructions that you have to approximate it. All right, let's do one more. Whoop, skip number 3 here. One more just regular straightforward one, and then we'll get into some applications of this. So here we do have a first step to do. Our coefficient on x squared is 3, so I'm going to start by dividing all the way through by positive 3. That's going to give me x squared plus 6x. I'm going to leave a space equals negative 5. So from here, I've already got, whoops, didn't mean to do that. I've already got my variable terms on the left side, so step 2 is now done as well. So from here, I'm going to go ahead and just add half of b squared on both sides. So half of b is 3. So if I add 3 squared on both sides, that's what it's going to give me here. That factors then out into x and whatever half of b was, so positive 3, equals, on the right side, 3 squared is 9. 9 minus 5 would be a positive 4. So we'll get a nice clean answer on this one. From here, that's already factored, so we're already down to step 4. I believe, let me make sure. Yep, step 4, factor it. And then step 5 here is just solve it using square root method. So I'm going to take the square root of both sides. That leaves me with x plus 3 on the left. On the right side, we get plus or minus 2. So that tells me I've got these two different possibilities. Either x plus 3 equals 2 or x plus 3 equals negative 2. That's what the plus or minus does for me. So I subtract 3 on both sides, and I get x equals negative 1, or here x equals negative 5. Those are my two solutions. All right, looking at this last section. This last section tells us, or asks us, to complete the square to convert each equation into standard form in standard form to vertex form. So now going back to like what we did last chapter with chapter 2, we have these equations in standard form. They want us to convert it over into vertex form and then graph it. Now I'm just going to do the first part of it because I know you know how to graph it once it's in vertex form, but let's go ahead and just work on converting it over. The only difference here between completing the square for solving an equation and completing the square on something like this is that everything happens on the same side of the equation. So when we get to that part where we add half of b in order to make it factorable, instead, because we can't add half of b on both sides, if we add half of b on the right side, we also have to subtract half of b from that side, which just makes it a little bit different. And I'll kind of show you what it looks like. Okay, so first things first, I'm going to go ahead and make sure first it's just x squared. Step 1's good. Step 2 is not applicable here. I'm going to go ahead and add a gap in between so that I can add in half of my b value squared. So now half of my b value would be -2. So if I add -2 squared there, because I'm on the same side and I have to keep it balanced, if I add half of b, I also have to subtract half of b squared. So it's a little bit different. Usually I add half of b squared on both sides of my equation, but since I'm just dealing with one side, if I add something, I have to also subtract it in order to keep it balanced. Because now what I'm putting in this set of green brackets, that is what factors. This would be x minus 2 parentheses squared. And now all the stuff that's outside of my green bracket can just be collected together since they're like terms. So this is minus 4, right? -2 squared is 4, so 3 minus 4 would be -1. And hey, look at that. We ended up with vertex form here without having to do -b/2a to find the AOS for that standard form and then plug it back in. With just that completing the square process, we can see that my vertex would be 2, -1, because my vertex form was always x minus h parentheses squared plus k. Pretty cool. We're going to do one more just for good practice. So here for f of x equals x squared plus 6x plus 5. Again, I'm going to go ahead and add some space in here so I have some room to add my half of b. Because again, my x is already my leading coefficient is already x squared, and it's just x squared plus 6x that I'm going to try and group together here. If I add half of b squared, I have to subtract half of b squared. So since half of b is 3, I'm going to add 3 squared and subtract 3 squared. That tells me these first 3 terms factor out into x plus 3 parentheses squared. And then on the outside here, that's 5 minus 9, so -4. F of x is x plus 3 parentheses squared minus 4. So my vertex would be -3, -4, because it's always opposite on the inside. So then from there, you could go ahead and graph it, but again, I'm not super concerned with it. So that's all I got for you guys for 3.3. Homework is on page 116, 4 through 36, every other even. As always, if you have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. And if I don't see you again, have a good weekend.